So here I'm just going to cover a couple of the more complex rules that can go with differentiation. So, for example, if I had something like e to the x squared, how do I differentiate this? It's a little bit more complicated than just e to the x. So what I'm going to do is I'm going to use something called the chain rule. Okay, and the chain rule basically says that if I want to find out what dy by dx is, in other words, I want to see how the function of y changes as I change x, well, what I can actually do is say, well, I can work out what the function of y when it changes with u, so dy by du, and if I can work out what du by dx is, then I combine these two and that will give me dy by dx. So in this case, e to the x squared, I'm going to have let u equal x squared, and therefore we have e to the u. So if we start off with y is equal to e to the x squared, now y is equal to e to the u. And so dy by du, what I get when I differentiate this, is equal to e to the u. Yeah, same as we had before. But now I also need to have du by dx. So here u is equal to x squared, so I'm going to differentiate this. I'm going to get 2x. And so overall, when I have dy by dx, that is equal to dy by du multiplied by du by dx. So that's e to the u multiplied by 2x. Or if I write that nicely, that's 2x e to the, but I'm going to replace u with what it was before, e to the x squared. So that's the use of the chain rule. The chain rule I always use when I have a function of a function, a nested function. So things like sine, I don't know, x to the 4, or the log of x squared again. And I can use the chain rule to actually explain why when I have the sine of 7x, that becomes, when I differentiate it, it becomes 7 sine 7x. And I can do this because in this case I'm going to let u equal 7 x. And so now du by dx is equal to 7. And so I differentiate sine u, that's going to become cos u. So I have sine u, and that becomes cos u. And so I have, that's my dy by du. And so now dy by dx is equal to du by dx multiplied by divided by du, which is 7 cos u, which is 7x. And so that's exactly the result we had before, just from our regular rules. Okay, the next rule I want you to remember is the product rule. So if I have this scenario of two functions multiplied together, so this is something like y is equal to x times e to the x. So I want one function multiplied by another function. This is the way we're going. And in this case, what I'm going to do is I'm going to say basically y is equal to u multiplied by v. And so my product rule is dy by dx is equal to u. I'm going to keep u the same, then I'm going to differentiate v with respect to x. And then I'm going to keep v the same and then differentiate u with respect to x. And so here in my scenario of y is equal to x e to the x, if I'm going to keep u the same, I'm going to differentiate e to the x, which is just e to the x. This time I'm going to keep e to the x the same and differentiate u, which is just x, so that's going to be 1. And so I differentiate this, and I'm going to end up with e to the x into 1 plus x. That's my answer here. My final rule is when I have one thing divided by another thing. And so this could be something like y is equal to sine x over x squared. Now, what I will say is in this case, and in quite a lot of cases actually, I could actually change this to use the product rule, which I've already done. So this is the same as x to the minus 2 sine x. And I could use the product rule. And I've chosen this one specifically to show you that I can actually make life easier if I can spot the product rule. So my quotient rule is a little bit more complicated. So in this case, this is u, and this is v down here, and dy by dx is equal to v du by dx minus u dv by dx all over v squared. And so in this case, I'm going to use the product rule here, or sorry, the quotient rule here. So I'm going to keep v the same, so that's x squared, and then du by dx, that's just going to be cos x, and then minus minus sine x, and then I'm going to differentiate this one, so this is going to be multiplied by 2x all over v squared, which is going to be x squared squared. I can rearrange this slightly, do a little bit of cancelling. So x squared squared, that's x to the 4. But then I've got x's everywhere, so I can cancel this x and make this one 3. And so this is going to become x cos x minus 2 sine x over x cubed. And if you go back, you can see that you can do this just using the product rule. Cases where I have to use the quotient rule are things where I've got sines and coses on the bottom. There's no other way to handle those ones. Hope this has helped. Please let me know if you want me to cover anything else.